Hey, what's up? It's Jake from Nimbus DevOps, and we're going to start out by talking about exceptions. All right, so let's go ahead and move all of the files I've been working on into this little archive guy, and we're going to make a new one called first.example.py. Okay, let me move this. We don't want to see all my old stuff. I have a lot of Python scripts. Okay, there we go. So even though we haven't formally introduced them to you yet, by now you should have a vague idea of what an exception is. So in the previous videos, we've like exhausted an iterator, for example. Called next, it raises a stop iteration. And you saw the index error when we tried accessing a list at a position that was outside of a valid range, like year or two old, and in my range 18 to 99. There's also an attribute error when you try to access an attribute on an object that didn't have, and a key error when we did the same thing with a key in a dictionary. So now it's time to talk about this in a lot more detail. So sometimes, even though an operation or a piece of code is correct, there are conditions in which something may go wrong. So, like for example, if you're converting user input from a string to an integer, maybe a user accidentally types a letter in place of a digit, making it impossible to convert that value into a number. So when dividing numbers, we may not know in advance whether you're attempting a division by zero. When opening a file, it could be missing or the file could be corrupted. So your code might work, but somebody might pass you bad data or pass you corrupted file or something like that. So when an error is detected during execution, it's called an exception. Okay, exceptions are not necessarily horrible, but we've seen that like stop iteration is deeply integrated into the Python generator and iterator mechanisms. So it can also be something completely normal. Normally, though, you don't take the necessary precautions. An exception will cause your app to break. And sometimes this is a desired behavior, but in other cases, you want to prevent and control those kinds of problems. So, for example, we may want to alert a user that a file they're trying to open is corrupted or that it's missing so they can either fix it or provide another file. So, you want to do this without the need for the app to die because of the issue. So, let me give you an example of this. So, let's say I have a variable gen and I assign a value n for n in range 2. Okay. In fact, let's just do this. Let me copy this. Let's just do it in an interactive shell. So I'm just going to type Python and then gen for n for n in range 2. So I want to say next gen, and I get 0. Next gen, and I get 1. Next gen. Uh-oh, I got an exception. And what is this? It's a stop iteration. So I can see a couple different problems coming up in here. Python's shell is quite forgiving. You can see the traceback, so you have the information about the error, but the shell itself still runs normally. It just said, hey, there's an error, and then it gave me another prompt, right? Um, it's a special behavior. A regular program or a script would normally just exit immediately, and if nothing were ever done to handle exceptions. Okay, so let me show you a couple other examples. So let's say I said print undefined name. And it says, uh-oh, it's not defined, right? If I make a list, I say my list equals 1, 2, 3. Okay, I made a list. And I say return list at index 5. It's going to be like index is out of range. Let me make this a little taller. The list index out of range because I only have 0, 1, and 2 elements. Let's see, what else? Let's make a dictionary. So if I said my dictionary equals, and then let's do some strings. Let's do A, and we'll assign a value capital A, and a little b, and a big B. There's a dictionary. And then if I said, hey, my dictionary, what is C? And it's going to be like error, right? You get a key error because that key is not found in the dictionary. There's a key A with a value A, a key B with a value B, but there's no key C. And then, of course, there's the classic divide by 0. 0 division error, division by 0. And you get these errors, but notice the shell. If you imagine the shell is your program, the shell doesn't cancel, it doesn't stop, it doesn't crash, it doesn't whatever, it doesn't exit. It just gives you the opportunity to type something else, right? So let's take a look at a code example, and let's do 1 plus 1. Now this is fairly simple, right? And then if I printed this line will never be reached. That's true because what's going to happen in my program is it's going to be like, I can't add this, I can't concatenate it because that's not a string. You're mixing your data types. That's not allowable in concatenation, and this is obviously not a integer or float, so I cannot perform an arithmetic operation. So this operator has the ability to do two different things, and neither of them are true, and so it's going to raise an exception, and then it's going to fail, and you'll never actually see this. And we can illustrate that here by calling this now, and it will just say trace back on this file, line 1, 1 plus the word 1, type error, unsupported operand for plus int and string, because I tried to add an int and a string. So because we did nothing to handle this exception, Python immediately exits once an exception occurs after printing out the information about the error here. So this is essentially the problem we're going to try to solve, is that in a shell, it would have given you this error and then it would have let you type something else. But in your program, as soon as it finds an error, if you don't handle that error, it's just going to stop right there and it's never going to go any farther. So that is what we're going to attempt to fix.